Hi there, my name is Adam Harris, Managing Director for Seatherm Technologies. Today we're going to be looking at characterizing some advanced fabrics and textiles with our TCI thermal conductivity analyzer you see here. We're going to be looking at today is a simple experiment, work done on three different types of materials. We're going to start with just a solid 100% cotton t-shirt, just as a point of comparison or baseline. We're then going to look at a t-shirt, the green one here, that is 60% cotton and 40% polyester. And then we're going to look at some more advanced materials, such as the gray shirt here, which is 66% micro nylon, 21% micro polyester, and 13% spandex. We're going to be measuring these materials with our TCI thermal conductivity sensor. The sensor is based on one-sided interfacial measurement, and the primary sensing element is this green sensor chip here. It's based on the same principle as how your hands can touch different types of materials and differentiate their thermal properties based on the buildup of heat between the sample and the sensor, in the case of your hands, or the sensor itself. So to test the sample, we're simply going to place it on the active area of the sensor, which you see here, and I'm going to use the extension plate here, just so we have a little bit more room in terms of placement of that sample. Now what we want to make sure is that we fully cover this active green area of the sensor. Okay, so we've got good coverage there. Just to make sure we get a good equal distribution and compression of the sample, we're going to place a piece of glass here, and then our standard weight. And the weight's there to ensure that we get a good contact with the sensor itself. We don't want to just put the weight on because it would cause too much localized compressibility of the material, is where the cotton is very compressible. So we want to displace that weight over the full surface area for consistency. Okay, so once the material is set up on the sensor, we go to our software, and you see the TCI thermal analysis software here. I'll try to zoom in on it. Sorry, it's a little bit shaky here. So we basically select New Test. I've already set up a special project for this, so we simply click on the Next. We pick our calibration. We're going to name our material. I've already inserted the name here as a cotton shirt. We click Next. And at this point, we're ready to start taking our measurements. The software is just looking for the sensor. It's located the sensor, and we're ready to press Start. So one of the nice things about the TCI is it offers a very fast measurement time. It typically, you can get 5 data points on a sample within 5 minutes. The measurement time itself is only 1 second, and the interval time between measurements is about a minute. And that's just to allow the sensor and the sample to come back down to isothermal conditions, so you can get a good, accurate measurement. So the status bar here is telling us what's going on, and I'll try to zoom in on that a little bit. I don't know if it's working well in terms of the resolution here, but we have our first result back. We're getting a value of 0.076 watts per meter Kelvin. I don't know if maybe we can zoom in there, try to clarify it. Well, we don't seem to get the very good resolution on the way I'm filming this, but what we'll do is we'll post these results shortly on our webinar that we're going to be launching later this week. And we'll review the results. We're going to look at the 3 different fabrics, and we're also going to look at their impact from a relative perspective, but then we're also going to look at it in increasing the moisture content of this material in applying some water to these materials and wetting them. We want to look at the thermal effusivity, absorbance of the material properties as the moisture increases. So for now, I'll sign off at this point, and we'll hopefully rejoin you here shortly with some results.